Welcome to a slow, beginner-friendly lesson on the for loop over a list in Python, made for absolute beginners. The loop begins. Today you write your first real loop. Until now you have written code one line at a time, top to bottom, and that is fine for simple work. But lists hold many items, and soon you will want to do the same action for every item inside. Print each name. Total each price. Search for a value. Doing that by hand, one variable at a time, does not scale. Python gives you the for loop exactly for this. Today, for over a list. Your first real loop, look at where you are. You can build a list. You can read one item by index. You can call len to count items. But what if you need to print every name in a list of 50 names? Writing 50 print statements by hand is painful and brittle. You need a way to say, do this one action, but repeat it for each item in the list. That mechanism is the for loop. It walks the list from start to end, and for each item, it runs your block once. From one to every. Until now your code ran top to bottom, one line after another. Today you learn to repeat, to walk a list, one item at a time, and do something with each. One item at a time. Here is the simplest for loop in Python. You write the word for, then a new variable name, fruit, then the word in, then your list, fruits, then a colon. Underneath, indented, the body, print fruit. When you run this, Python takes the first item, apple, assigns it to fruit, and runs the body. Then banana, runs the body. Then cherry, runs the body. When the list is exhausted, the loop ends. Same body, 3 times, 3 different values. 4 pieces, 1 body. Let us name the part so you can read any for loop you meet. The word for begins the statement. Then a variable name you choose, it holds the current item, one at a time. The word in separates the variable from the list. The colon ends the header, exactly like def and if. Underneath, the indented body runs once per item. 4 pieces, 4, a name, in, a colon. Then the body. That is the whole shape. Name the parts. The colon and indentation work here exactly like in def and if. The colon says, the header is done, the body follows. The indentation, 4 spaces by convention, marks what belongs to the loop. Forget the colon and Python raises syntax error. Forget to indent and Python raises indentation error. Unindent to leave the loop. This is the same rule you already know from defining functions and writing if statements. The muscle memory transfers directly. Same rule as def and if. A list has an order, first item, second item, last item. The loop honors that order. It starts at the beginning and walks forward, never back, until the list ends. Forward, in order. Picture what happens when the loop runs. Python stands at the start of your list. It takes the first item, gives it to your variable, and runs the body top to bottom. When the body finishes, Python steps forward to the next item, gives that to your variable, and runs the body again. Item by item, in order, from first to last. When there are no more items, the loop ends and your program continues on the line after it. One body, many passes. Picture the walk. Let us slow down and watch one loop in detail. Fruits equals apple, banana, cherry. The loop starts. First pass, fruit becomes apple, the body runs. Second pass, fruit becomes banana, the body runs. Third pass, fruit becomes cherry, the body runs. There is no fourth pass, the list is exhausted. The variable fruit still holds cherry after the loop, but you usually do not rely on that. The point is, same body, 3 passes, 3 values. Same body, 3 passes. A common need, print every item in a list, 1 per line. Before the for loop, you would write print of name square brackets 0, then print of name square brackets 1, and so on. Painful. With a for loop, write print name once, and Python handles the rest. Each item lands on its own line because print adds a new line by default. One line of body code does the work of many. That is the power of a loop over a list. One line, many outputs. Sometimes you need both the position and the value. Maybe you want to say, item 0 is apple, item 1 is banana. Python gives you enumerate for this. Write for I, fruit and enumerate fruits colon. On each pass, I is the index starting at 0, and fruit is the value. Enumerate pairs them for you. This is cleaner than tracking the index yourself. 2 variables, 1 loop, position and value handed to you together. Use it whenever the index matters. Position plus value. Enumerate deserves a moment. It takes your list and returns pairs, a number and an item. The number starts at 0 by default and grows by 1 each pass. You unpack the pair into 2 variables, index and value, right in the for line. If you ever wrote a loop in another language using an index variable, enumerate is the Pythonic version. It is clear, it is safe, and it reads like English. Reach for it whenever position and value both matter. Pythonic and clear. Before you learn enumerate, you might try looping with an index manually. For I in range of len of fruits : then print fruits square brackets I. This works. Range of len gives you 0, 1, 2, the valid indices. Then you index into the list inside the body. It is correct, but it is more typing and more room for off by 1 errors. When you only need values, use a plain for loop. When you need position too, prefer enumerate. Both have their place. Works, but prefer enumerate. Here is one of the most useful patterns in programming, the accumulator. You want the total of a list of prices. Start a variable called total at 0 before the loop. Inside the body, add the current item to total with plus equals. After the loop, total holds the sum. Walk through it, total 0, then 5, then 12, then 20, then 32. Each pass adds one item. The variable grows, or accumulates, until the list ends. The accumulator appears. Notice the shape of the accumulator pattern. 1. Initialize a variable before the loop, total equals 0, count equals 0, largest equals nothing. 2. Update that variable inside the body, add, increment, compare. 3. Use the result after the loop. The setup before, the work during, the result after. Once you see this shape, you start seeing it everywhere. Sums, counts, products, maximums, minimums, all follow the same 3-step recipe. 3 steps, every time. Counting is just summing with a condition. Suppose you have a list of scores and you want to know how many passed. Initialize count at 0. Loop over the scores. Inside the body, if the score is greater than or equal to the passing mark, add 1 to count. After the loop, count holds your answer. The shape is identical to the sum. Initialize before, update inside, read after. You are still accumulating, you just decide, on each pass, whether to add. Same recipe, with a test. Finding the largest value follows the same recipe. Initialize largest to the first item. Loop over the list. Inside the body, if the current item is greater than largest, set largest to the current item. After the loop, largest holds the maximum. Walk it through, largest starts at 3, then 9 replaces it, then 12 replaces that, smaller values are ignored. By the end, only the biggest survives. Finding the minimum works the same way, flipped. Keep the largest so far. Some loops build a single answer as they go. A running total. A count. A maximum. The variable grows, one item at a time, until the loop ends and the answer is ready. The answer grows. You can also build a brand new list inside a loop. Start with an empty list, squared equals square brackets. Loop over a list of numbers. Inside the body, compute the square, then append it to squared with squared.append. After the loop, squared contains every result, in order. This is the append pattern, and it is how you transform one list into another before you learn list comprehensions. Initialize empty, append inside, use the full list after. 3 steps again. Empty, append, use. A string is iterable too. That means you can loop over it character by character. For ch and hello : print ch. On the first pass ch is h, then e, then l, then l, then o. Python treats the string as a chain of characters and walks it the same way it walks a list. This is powerful. Count vowels, uppercase every letter, find a substring. Wherever you have a run of characters, the for loop works. The pattern you learned for lists applies to strings without modification. Strings walk too. One mistake every beginner makes at least once, changing the list while looping over it. Suppose you remove items from a list as you walk it. Python tracks its position internally, and removing items shifts everything left, so the next item gets skipped. The loop sees a moving target and silently gives wrong results. The safe fix: loop over a copy, for item in list of nums : the wrapper makes a shallow copy, and modify the original inside. Iterate over a copy when you must change the original. Iterate over a copy. Here is the whole lesson in one breath. The for loop walks a list item by item. For, a variable, in, the list, a colon, then the indented body. The body runs once per item. Use enumerate when you need position and value together. Use the accumulator pattern to sum, count, or find a maximum. Initialize before, update inside, read after. Strings are iterable too. Never modify a list while you loop over it, iterate over a copy instead. That is for over a list. For over a list, in one breath. Where do you go from here? You now have the for loop over a list. Next you learn conditions, the if statement, so you can decide inside a loop what to do with each item. After that, if and else together, then elif for multiple branches. Once you can loop and branch, you can write real programs, filter a list, transform data, search for values. Loops and conditions are the two tools that turn a script into software. The next lesson opens conditions with if. Conditions come next. Thanks for walking your first list with for. Next we add conditions with if. Onward to conditions.